Thank you very much for your invitation. Hello everyone, I'm Karina. My presentation is about query processing and multistore systems. So very quickly, this is the structure of my presentation. I will first introduce what is it, multistore systems, and I will give some state of the art about it. After, I will talk about one of famous multistore system is called CloudMdsQL, what we use here in European countries. And I will talk about extension of this multistore. After that, validation, and finally, I will conclude and give some perspective about this work. So, in one word, what is multistore system? Multistore system is just, it's called like system that provide, for example, last time I talked about, for those who attend my first talk, I talked about data. So when you have data, even if you are in mathematics, physics, you have some data, for example, you need to store it in order to process if you are data scientist too. So this kind of matter or this kind of problem, if we want to process all of, we want to process data, we need to store data. So data are simple, can be simple or sometimes difficult. So it depends on the kind of data. If we want to analyze or to process all data using one system, we need to use the multistore system. So for example, the system can provide or can access or store NoSQL data, a simple file system, relational data too. We can give an example of work about it: Polybase, ParsQL, LinkScale. So I will give you a kind of problem we try to solve here. For example, I have a query. A query, what is it? I have, for example, one problem. So one problem, I want to analyze, or, okay, I want, for example, to analyze data, and I ask a question. So I call it the query. For example, in interest, I have a query queue. The question here, how to process it. So I need to do some optimization, but where is it? Will I start to optimize my data here or in one of the store? So my question would be, for example, how many person will come, for example, in this conference in 2000, for example, and 22. Okay, so how could I process it? I will ask question. It's a kind of prevision because I'm trying to know something about the future. Or I will give this question here, knowing that in each store, so in each database or data store, I have some data. For example, here I have a name of a participant in 2001, for example. Here I have a name of the list of each articles here. Here, for example, I have in this one, in this file system, for example, I have a list of, I can check the list of different conferences in Nigeria. Okay, so why do I need to put each part of data in different store? Because when I ask a question, I have, for example, this question in English, how many? But the system don't know what is how many. So I need to process it in order to see what am I asking to the system in order to check if this question can be answered by each store. So this one is the problem. But even if I have my question, I need to check. I have different data store. In each one, I have different data model. What is data model? Data model is just how I store my data. For example, if I have participant, I can't put it just like that. Maybe I can use a kind of model or a kind of structure in order to insert my data here. But the structure here is different from this one. So the first one, I have different structure, semantics and syntax. Here too, I have different semantics and syntax. In this one too, I have different, because this one is just the file. It can be Word file, for example. And I store each conference here. So I have many conferences in this file, for example. So based on this, we need to store, we have a problem. And with this problem, we need to take into account this one, the data model, the language. For example, if I want to store or to access my data here, for example, I can use Java. This one maybe Python, this one maybe Java 2. So each part, I store its data store in different parts. For example, this one, I store it, for example, in Abuja, this one in Lagos, this one in Benin, for example. So the state of the art say that we have three kinds of that multistore. What is multistore? As I said, is a set of this. All of this is called multistore because we have different store and in different languages, different models, different nodes. So we have something loosely coupled, tightly coupled, and an hybrid multistore. So if I take this one about loosely coupled, the schema here, I gave some implementation techniques in order to see how could I optimize my query. We know what is query. So if we want to run this query in order to answer to the client, we need to optimize it because we have several stores and we don't know what is the best way to run this one and where could we run this one. So we have an heuristic. It's based on some rules in optimization. Okay, we have a cost base. It's based on statistics, for example, and we have some cardinalities. For example, if I run first part in this one, how many input output, the cost of output input, the cost of optimization, the cost of many things. So based on this, we say that we have a loosely coupled, a tightly coupled, and an hybrid. So for all of this, we have a special modules. For example, if we want to process our query, the schema models, the query processing, and the good part is query optimization techniques. So I talked about CloudMdsQL Multistore. So what is it? We work on this with in the context of an European project called Current Pass. So the goal here is to design on query language in order to process our data to query multiple database. And the second part, we designed a query engine for this language. So if I take this CloudMdsQL, we say that we want to query our data. It's based on three kinds of expressions. One part is the native tables. We use a query as we take it. We have another part about SQL, and the last one, Python, in order to process and to produce a relation. For example, one example of CloudMdsQL. So I say that we are using Multistore. This Multistore here is called CloudMdsQL. So in this one, we have three data sources with three data stores, 1, 2. And the last one saved or stored data from this part and this one. What I'm doing here, for example, I have one table. This table is called T1, okay? In this T1, for example, I have 2 columns. So I have X and Y. This one integer, this one too is, the type is integer, So I store all of these in first data store, I call it DS1. And I say that here, I want to select X and Y from A. So my database, where I store my data is T1. This table, I call it A. I want to select all of this, all rows. For example, if here I have 1, this one, 100, sorry. This one I have 2, for example, 5. So the result will be 1, 100, and 2, and 5. But how could I do it? The result will be this one, okay? But beside, or when I go back into the detail, I used some statistics in order to process this one and to have this result. I have another data store. I call it data store 2, for example. And inside, I have another kind of data. I have X, for example, but the model is not the same thing. The syntax is not the same thing. I don't use this kind of format, model with row, and column. It's different. And the result of this one, here, I need to find or to select X, okay, is a field, and the value 10. I want to take 2X, for example, with value 1, and that value 1. So I want to select just X and Z. For example, 1 is Y because I want to take it. This one too, I want to take it. 0 because I don't want to take it. It's what I said here. So the result of this, it will be the combination of the star 1 and the star 2. So I give an example. For example, if I want to process my data using some file system too, it's really difficult. Why? Because, for example, I have an editorial office and I need to find appropriate reporters for a list of publication based on the keyword. Here, I have a timestamp. So in this file, this one is a file. This file consists of or inside I stored some posts. And for each line, in each line, I have timestamp, okay? I have the publisher, for example, and the used the keyword used that Alice used. Here two timestamp, for example, publisher and keywords. Timestamp, publisher and keyword, for example. But here we can notice that here we have two keywords, here we have three, and here we just have one. How could I give an answer based on this? Because here I have a post, and in other part I have a publication. So here you can see it's structured because I have here one table with title, author, and keyword. So what I need to do first is to process it by using Spark part. Spark is just a it's enabled to process my data. Okay, so by using this some function based on Spark, I can produce this result. So I will have a kind of table here with keyword, expert, and frequency. So for example, Cloud, Alice, twice. Okay. Storage, Alice, once. Virtual, Bob, just one time. App, Bob, just. So it's based on this. I don't need to use this one in order to answer to this question. Okay. And the result of this, I will combine it. So this join is a kind of function. Okay. And based on this, I have some statistics in order to see the cost of using, if I use the cost, if I use this one, or the costs if I used this process part. So I have another example. I want to count, for example, the word that contain the string cloud. So what could I do based on my CloudMdsQL Multistore? I can scan, for example, the text. So I have here the data set. The data set is just a set of data. In this set of data, I have a file, and in this file, it's just a file, and in this file, I have, for example, each publisher, the timestamp, for example, and the keyword. Okay? And inside, I want to scan it. I want to scan the text. Okay? What I will do? I will do some map function. This one, I have a cost of this too. I know what is the cost of using map function. So I will take each key and try to count. So just first one, for example, if I take key, cloud, okay, one, for example, mathematics, one, physics, for example, one, and what we want. And I will use this condition. For this one too, I have a cost of using this. And I will say that I have this filter. I just need to take the key to check in my file if I have this key, and the key is equal of this keyword cloud. And after that, I will do some sum to combine all of this and to count how many times I used this keyword. So this one too, here I give a good example in order to clarify here. For example, I have here two data stores. The first one is a simple, I just want to select, I have one table, for example, with title, because here we used you published some articles. So you have, for example, the title. So the name of this, for example, is article. Okay, and you have a title of your article and the keyword. It can be, for example, optimization. It can be here, for example, mathematics or linear. And for this one, the title, for example, optimization by using in order to solve, for example, linear problem. And here I have just one text file, and I save it in a file system with some words and different key. And I have a kind of query, I call it a subquery. Why? This subquery will take the result of this one and combine it with this and retrieve the answer to the client. So in order to process how I said, to clarify everything, how my system can process or to optimize the data. So I have, for example, one client. My client sent a kind of query, just a question, if so many question tag, for example, to the query engine. And this query engine will transform this query in query execution plane. I will explain what is it. So based on catalog, in this catalog, I have statistics, okay, and some rules inside. And here, after checking, they checked if I can, where could I send each part. So, for example, I have different questions and I need to execute each of these in the right store. Here I have 3 stores. I have the first one is a file system, the second one is just a document system, and this one is a structured system, for example. So I sent each question, sub-question in the right store. But in order to collect them, we need first to translate each part in order to be, in order to process it in the right store. So the wrapper, we can collect this question called query and translate it by a by using some, for example, write rules and statistics inside of this in order to process it in the different parts. So after this, we will take each part and give it to the right part in order to give the answer to the, in order to give the answer to, so this answer to the client. So now I can say it. This one is a query execution plane. Okay. The first one is this one. This project is a kind of function. In this function, we need to, for example, if we have a table, okay, with 2 columns, X and Y, we just need to select all of this. For this one, is the same thing. I say that we have here we have one document, and in this document we have 2 fields, X and Z, and we need to collect all of this. And the answer of this one, I will put it together here in this CloudMdsQL system. So based on this, we can see we have 1, 2, 3, 4, 5 functions. But in order to use it, we need to check the cost. If I use, for example, I try to execute this one in this data store, in the relational structured data store, what will be the cost? And we check the statistic, the cost, and the rule. So the rule is what? It's better to start by selecting, for example, this x less than 3, for example, in this data store. And after that, to use this project in order to select just the good x. And the last one, to take, for example, after selecting x and z, and to put all of this together. By using this, when we check our statistics, we use less data and less resources, for example. So it's the same thing here. I have, for example, in this one, I just need to select X with A, B, C, ID 1, X, Y, Z, ID 3. And in this one, I just need to select, for example, Y with ID 1 and 3 for X9, for example. So I use some parts, and after the result of this, I will select it and put it together inside of my query processor, what I already mentioned. So the result will be what? It will be ABC for this one and X for this one. But this one, I will give it to the client. However, the client doesn't know what is the statistics, what kind of rule I used in order to produce this result. So the last part, I can introduce the good validation, because if we want to validate what we said, we need to use real data. So we use the 3 kinds of data sets. First one is about the posts. The second one is about the scientists. And the last one is about the publication. For example, for each publication, we have a title, over, and the keywords, as I said. But we see the format is not the same one. We have here different model. For example, this one is a file, timestamp, publisher, and the keyword. Here we have a name, affiliation, and the country. We can see here we have a correct structure. It's structured because we have 1, 2, 3, 4, 5, 6 rows, but here it's different. We don't have a table. It's just a kind of simple data with a field, value, and field value. So this one is an area, is a set of keywords. So the question here, we ask to the system, we want to find, for example, appropriate reviews for publication of certain over. So we have this queries. So the first one about scientist, I want to take the name, affiliation for this scientist based on this table, name and affiliation. And for this one is a Mongo subquery. I just need to select other title keywords. So it's based on this, title, others, and keywords. And the last one is integration of this part and this one. So this one here, I want the third subquery question. I will give here my post, and inside I just want to collect, for example, each publisher and the correct keyword, and to count how many times the publisher used this keyword, and to integrate all of these insights of this query. So at least we will select other, title, keywords, and each expert. And just to find affiliation equal in area. So the last answer will be normally this one. We will have Patrick, in area, France, and the correct keywords based on Patrick. For example, the title of the book, the authors, and the keyword used by Patrick's cloud and storage. So we don't optimize. We don't need to optimize for the first time. What is optimization is to use, for example, some heuristics based on statistics and some cost and the rule base in order to see which kind of what kind of function we need to use first in order to reduce some costs. Here, for example, I have other title and keywords. So the name of this one is Patrick. We have two kinds of store. And this store gave us, when we join together by using this function, we have this result. But inside we have the post with keywords. And we can have, for example, 1 tera post, okay? It's too much. We can't process it like that, because if we want to process it, we need to execute first line, the second line, till the end of this. It will take time. Or the goal of query optimization is to reduce the costs, for example. So we want to reduce some costs. For example, input, output. We want to reduce, for example, the optimization costs and the time on this execution. For example, if we don't take it to account this one, we can do this one in 1 month. Or if we optimize, we will prune, for example, what is not correct. In here, we see that here we have 1 tera. If we prune, maybe we can use just 2 lines, and we will prune what is not useful by using this condition filter in order to prune and to save just what contains or what contain 2 keywords, cloud and storage. So how will I use it? How could I remove what is not necessary? In order to use it, we use some function in our system. We call it pushdown. Why pushdown? For example, here I have one data set. This data set is this file. I have date, the correct user, for example, publisher, and the keyword. So I will apply first one. In this one, how we said flat map is just a Python. We use the lambda function with Python in order to take each line, so each keyword with the correct user, Alice, for example. So we have this one, the set of each, the pair of keywords and publisher. And after that, I will have the set, but here I will combine this one by using the map. So I will have a kind of tuple and the frequency. So here, cloud, Alice once, storage, Alice once, cloud, Bob one. So I mapped all of this. And after that, I will count by using this function. If I use it, I have some costs. So cloud, Alice 2, storage, Alice 1, for example. Why here is 2? Because I already use it here, 1 and 1. So if I combined, 1 plus 1 is 2. Storage, Alice I just have it, use it once, CloudBob one time, here too. After that, I will map again, but you will see that when I will map, my pairs will be different because here I will separate by using which function. I will have the cloud, only the keyword, and the pairs will be Alice and 2, so frequency, the number, occurrence. So after that, I will use reduce in order to count again, and filter in order to select the condition, because here I just need to take all publication based on the keyword cloud and storage used by Alice. And the project will enable to set all of these by use a structured way. So I will have a kind of table with keyword and expert, Alice. I did the same thing. So I will write by using some expression, we called it reduce and filter, in order to push my filter condition yearly. So you see that here is at this filter is here at the end of my query, but here I try to push it quickly. When I will push it quickly, we can see that we use the costs, the time of execution is, it can be 2 minutes or 1, it depends on how many data you have. For example, input, output, we don't use many storage, just one part, and we need to take into account many parts. So here I will write my Spark code in order to process it, for example, using our expression. We call it MFR, map, filter, reduce, what I gave here. And we need to take into account some performances. For example, if we use optimization techniques, so statistics, rule-based, heuristics, in this graph you can see, for example, and the selective factor too. You can see I have one query in different parts, and the second I used by using optimization techniques and without, by using optimization techniques and without optimization techniques. You can see we lost time without using optimization techniques. Here, for the same query, different queries with different selectivity factor. With our statistics, we can see that the time we lost by using by executing without optimization techniques. So, in conclusion, I can say here I give you some introduction how you can use, for example, mathematics or statistics in order to process the data. Is one part of work some data scientists can try to make in our company. So based on some state of the art, we compare different approaches, and we try to extend our CloudMdsQL by using some notation in order to process what is stored in a different way. And we take into account query optimization by using some reordering operator or functions, rule techniques, for example, session pushdown or bind join. And to validate it, we use a nodes or a kind of computer in order to process the data. So this was some perspective. We about this work, and all of these we published this work in some journal paper. We produced already some journal papers and some conference papers too. So thanks for your attention, and now you can ask questions. Thank you.